is well. All right, there we go. Hey, welcome everybody once again to Astronomy Daily Live. It's 2 hours UTC on the 1st of May, 2019. It's
Here we are.
pretty incredible that you know uh, time uh, is such a slippery thing. Sometimes it seems to go by really fast. Sometimes it seems to go by really slow. Uh, but so the first couple of months, at least my perception, at least, was that they were just going by really slow, and I was absolutely loving that. That was absolutely great. It's like, wow, wow, it's only January, whatever it was, right? And then March came, and all of a sudden it's the 1st of May, and I'm sort of like, I think I've lost a couple of months here, really. So yeah, it's pretty amazing. But yeah, this is the first live stream for the month of May. And all right, well, cool. I'm gonna pull open live stream. Bobby, you gotta turn that down, dude.
Wasn't me.
All right, Arthur, you gotta turn that down. Pull open. Oh, she's frantically typing. Bobby, you gotta turn that down, dude.
Wasn't me.
All right, Arthur, you gotta turn that down. All right, somebody turn that down, dude. Greatly misbehaving, and I don't know. Yes, I muted you, Atta, and the echo went away. Do you have a YouTube running in the background anywhere? Perhaps? Uh-oh.
We lost her.
Yeah, we lost her. Well, she'll come back. No problem. She was sacrificed on the altar of echo and just out of there. So yeah, well, hope everybody's doing well. So this is Astronomy Daily Live. You can call me Cosmic, and we spend the next hour-ish or so talking astronomy and space and science and all kinds of nerdy things. And what I like to emphasize with this live stream is skepticism, open-mindedness, and curiosity in the extreme. All three.
Is tricking out her library to see books.
And curiosity. Yeah.
And I can still hear that again.
Yeah.
I don't know what's causing it.
You don't have no headphones? You hear that again.
I think you might have to mute yourself, or get your headphones on.
Hear that again.
That's it.
You got it? Yes.
Yeah, that's it. Somehow the mute came off. Usually I have it muted.
Oh, okay. Yeah. Well,
I don't know why it wasn't this time.
These these machines are slowly making their plans against us.
That's not it.
All right, forget that.
YouTube earlier, and I took it off mute.
Cool.
I forgot to put it back on mute. When I come in here, I have to get it on mute.
Yes, that's absolutely true. Anyway, so let's get it going. I want to definitely say howdy to Bobby, also on the panel. What's going on over there, Bobby?
Nothing much.
So,
Yes.
So you made a special request after the live stream yesterday, for us to do, or for me, I guess, to do a rabbit session, because it was the first of the month, and you sort of wanted to celebrate that, which I am completely in favor of. And so yeah, after this live stream here, I'm going to share my screen really quick, and then I'll come right back. I just want to show you what I'm going to be showing over on the Rabbit channel. So we're going to be looking at Gaia. I sort of thought, I was going through these talks. These are a lecture series that is put on by, as you can see, the Harvard Smithsonian Center for Astrophysics, so-called CFA. And last October, I was looking at their video list, and I noticed this one, and it's all about Gaia, and it's like, that's pretty timely. So I think I'm gonna show this. But it's just a little over an hour long. So right after this live stream, I will open up my Rabbit room. Is that what it's called?
Something like that.
Yeah, and we'll just sit back and watch that lecture. The CFA lectures, if I remember right, aren't they're, I don't think they're incredibly, like, way over the head, but they're also not like for kids, right? So they're pretty much right in the middle, pretty digestible, pretty understandable. So yeah, I think it's going to be fun.
And last time I checked about Rabbit, for the Android and iOS, they only meant it for the phones only. They didn't have a tablet version. So I'm not sure if that changed yet. I just have it on my phone just in case.
Okay. Well, yeah, I think the only requirement with Rabbit is that you definitely have to sign up for it. So
yeah.
So that's really the only disadvantage, I guess. And I'll post a link to that Rabbit, my Rabbit channel over on the chat there. So I'm pushing all kinds of wrong buttons here. Hold on, let me do that. Okay, there we go. These machines usually do exactly what we tell them.
Members of the United Federation of Planets. Live on and prosper.
PageMaster, if you're aware of other members of the Federation, please let me know. Because I've got some things to say. So just let me know. Anyway, so let's look in the chat here. So Tom, hey, nice to see you over in the chat. There's Nightbot Chuck. Great to have you back. Great to have you back. Astro Live channel. Hey, what's going on over there? How's the weather in Colorado? I think you're in Colorado.
I think another day is we might have to help Ron from Earth Radio with a little bit of content, because I think for some other reason his internet kept on cutting out.
Oh.
And it's one of those bottom 10 list of internet service providers.
Okay. Yeah, I thought I was on the bottom of that list. Oh well.
Yeah. I've been hearing a lot of negativity about not only just FedEx, but also CenturyLink, which is Ron's provider.
Yeah, actually, one of the possible providers in my area is CenturyLink, and I think I'm kind of happy that it's not my only choice. So yeah, CenturyLink has a little bit of a reputation that isn't also all that great. Arnstro, hola, ¿cómo está?
Yeah.
What's happening?
¿Cómo estás, Arnstro?
Glad you could join us. Always great to have all of you here. It's you know, I think it's absolutely fabulous, and you know, of course, you're always welcome, you know, to come in anytime. If you want to come in every single day, that is great. You know, my job is to be here every single day, and my job is easy. Once in a while I can't, but for the most part I can, and so yeah, feel free to come in anytime you would like, any day, any week, any month, any year. Atta, are you making weird uh, views over there? Is that what that is? No, not at all. All right, well, cheers. I've got the hydrogen hydroxide again today. You know, I should have grabbed the dihydrogen monoxide because I'm going to be up a little bit late with the rabbiting, but this is okay. You know, it's a nice mellow brew, so you know, I think we'll be all right with that. So cheers to that. Atta's got her her Spock mug there, which you know, that is one of the blackest mugs. Oh, and it's got the ears. I didn't notice the ears before.
Yeah, definitely.
Oh, that's fabulous.
Mug with everything. Has ears.
But it is so incredibly dark. I don't think I've ever seen a dark like that. Now, is his face a grayscale, or is it sort of...
Oh, no. Well, yes, it is. It would be like a black and white photograph.
Okay.
It's really kind of creepy. It looks alive.
It is super creepy. It is just super creepy. I like it. I like it. And it's a nice big mug too.
It is. It's very big. It's 20 ounces.
Nice. Yeah. You
mug shot. Oh, Chuck, give me a break.
Mug shot.
And I got my faucet water here.
All right. Excellent. Nice mug shot. Yes. Yeah. I've got a great group of people here. Well, we have a great group of people here. I'm so greatly impressed and blessed and honored, you know, to have you all here. I think it's absolutely great because I just want to share, you know, the passion you know, that I have for science and astronomy and all that. And I know that there are, you know, thousands and thousands of others that feel exactly the same way that I do. And that's sort of why, at least one of the reasons why I'm doing this live stream, is to sort of find that worldwide community, which is definitely out there. We already have a community here that is worldwide, and I think over time it's just going to grow. You know, I'm not too worried about that. I think that it's just going to happen. So yeah, you know, my job, as I said, is just to be here consistently and you know, as enthusiastically as I can. But I'm incredibly enthusiastic about astronomy. So that's you know, no effort whatsoever. All right, well, cool. So I was investigating our globular cluster NGC 6397 a little bit more, and you know,
and speaking of like objects up in the sky and stuff, did you see Page Master's latest photos?
I
of the
did.
Messier. Yeah.
I did. And the and PageMaster, you can answer this in the chat if you want. But I'm curious why you seem to have an interest in the Caldwell objects. Is there something particularly interesting about them? What's the fascination there? Is it yeah. I just like to know, because I'm not quite sure, and I guess I should look into it a little bit more. And if you want to post a link to sort of what the Caldwell objects are all about, that would be really, really great too. Is it just, there was somebody named Caldwell who discovered these, or do these objects have a certain sets of characteristics that sort of put them into a
I
group?
forgot who called them the Caldwell group. I forgot. I think it was Patrick Ward, if I recall correctly, that did the Caldwell.
Yeah. Okay. Yeah. That's something that we can actually investigate here too. But if PageMaster wants to provide some links and stuff, and then we can share them at some future time, because there's all kinds of different catalogs of objects. There's the Caldwells, there's the ARPs, there's IC, there's NGC, Messier. It just goes on and on and on and on and on.
Kind of like a bit weird that the only one we knew better was like the Messier and the NGCs.
Yeah, well, those are sort of the most popular ones, and sort of I can't really say that they're the most interesting ones, because they're all incredibly amazing. Anyway, so I was looking into NGC 6397, and it dawned on me. It's like, I need to see if Burnham's has said anything about this globular cluster.
Okay, so PageMaster, something that he stumbled on by accident while looking up the Messier. It was developed by Sir Patrick Alfred Caldwell Moore.
Cool. Okay. Yeah, we should probably spend a little bit of time over the next few days or weeks or whatever it is, and look into that a little bit more. I'd like to find out a little bit more about that catalog, because I don't know much about it. And actually, let's really quick, let's go over to my Discord channel, and let's just look at the Caldwell object picture list that PageMaster posted. And I'll do this pretty rapidly here. I love tangents, but let's not get too much into this tangent, or we'll never come back. So, okay, here we go. So let's sort of see what these are all about. So it sort of looks like there are some planetary nebulae, right? There's some galaxies. Ooh, this galaxy number 38, I recognize. That's NGC 4565. So that's a nice one. This is also a galaxy that I recognize. This is NGC 891. Trying to see if there's any others. I think this planetary nebula is the Saturn Nebula. This guy here. But yeah, it sort of looks like it's galaxies and nebulae, both planetary and gaseous. Galaxy, cluster. I think NGC 6397 was Caldwell 87, or was it 106? I don't remember now.
Yeah, I forgot too.
Maybe PageMaster remind us
Yeah.
which of the Caldwells it is. So
Now,
it's
what's
a
the
mix.
NGC number again?
The NGC number that we are looking at is 6397.
All right.
6397.
63.
I've actually got it right here, so we can actually find out.
It's 86.
Okay, it's 86. Okay,
Yeah.
cool. All right, so it's that one. Okay. All right, very good. So it looks like the Caldwell objects are a mixture of objects, just like the Messier's are. Oh,
Yeah,
here's
when in doubt, get the Stellarium mobile basic app. I think
there
it's
you
worth
go.
the $2.99.
Yeah, I totally agree. Here's the Eskimo Nebula right there, Caldwell 39. It looks like. So cool. Yeah, so it looks like it's a mix. It's hard to tell if there are any open clusters in this. Maybe 102 down here, maybe 94, maybe 96 and 95. Kind of hard to tell, but um, pretty nice. Pretty nice. All right, let's not get too incredibly pulled into the Caldwells. Stop sharing. So what I did, and I need to remember to do this, is I went to my Burnham's Celestial handbooks, which, this is a 3-volume set, and this object is actually in the constellation of, I guess you'd call it Ara, A-R-A. And it's sort of a southern constellation. It's just west of Scorpius. So it's not very far south, but it's kind of a small constellation. I actually don't know all that much about it, so maybe we should investigate the constellation itself at some point.
Right.
But
So, before you do continue, we got a possibility of more meteor scatter as Earth nears the remnants of Halley's Comet, which is going to peak between May the 4th and May 6th.
oh, nice. What shower is that?
I'm about to find out right now, my friend. I think it's called the Aquarids.
Okay, cool. The Aquarids. Is it just the Aquarids, or is there like a Greek letter at the beginning of the like an Eta or anything like that? It's just the Aquarids.
It's the Aquarids, yeah.
Cool. Okay. We can. Yeah. Nice. And that is the cloud of debris that is left by comet. Which one? Halley?
Halley's Comet.
Cool.
Or Halley's Comet, one of the two.
Yeah, that is one of the things that I don't sweat is pronunciations. Don't don't worry about how these things are pronounced. There are lots of different ways. Unless there's that kind of name, there are at least 2 pronunciations. So it's like whatever one works.
Okay, so on Astro just posted a link about Ara. I think I selected from the drop down menu too.
Okay, cool. Yeah, we'll have to dive into that a little bit. So anyway, I've pulled out my Burnham's Celestial Handbook, Volume 1, because what Burnham's does is they've ordered things by constellation name. So of course Ara begins with A, so it's in volume 1. Now I've had these books since maybe about 1980. or so. So as you can see, this particular one, I've somehow held on to the cover, but it's completely off, and it's got a little bit of what is clearly very clearly kitty claw damage there, right? Otherwise, it's actually in pretty good shape. You know, this is a little bad, and you know the back is okay, but you know these books have moved around a lot, and they have been used quite a bit. Anyway, so I'm going to go. Volume 1 goes from Andromeda through Cetus. So we can definitely go here and find Ara, A-R-A, and it's right before Aries. And sort of surprisingly enough, they have Burnham's has an entry for NGC 6397. And because, you know, I was looking at the Sinbad entry. I'm going to try to get this thing to focus here. Bam. Okay. And there are like over 1,700 references listed in Sinbad. So that you know that's an unusually high number of references. So it's like, you know, why is this object so interesting? Well, one of the reasons is because, at least according to Burnham's, and when this was published, which was, you know, I think this this particular volume, let's see, 1978. Okay, so as of 1978, which is like 41 years ago now, holy moly, it was believed and understood that this globular cluster was/is the closest globular cluster to us. And yeah, that makes it extremely interesting because, you know, the closer things are, usually, you know, the sort of the better we can see them. And that's absolutely true. You know, when we looked at the HST images, we were able to go right into the center of the cluster and pick out the individual stars. Most of the time, you really can't do that because, you know, the stars are so densely packed and so far away, you know, that they start to overlap each other a little bit. But in this case, it definitely can, and that's because it seems to be so close. So here's a picture of it that is published. I'm just going to move this cover out of the way because otherwise I'm gonna. So that's how it appears in Burnham's, like that. So yeah, you know, it's a nice glob. It's a nice glob. If you compare that to what we were seeing last night with Gaia, it's you know, the difference is pretty striking. But at least according to this book, and you know, we'll look at some more modern measurements too, but they put it at 8,200 light years, which yeah is pretty close as far as globulars go. The globular clusters, they sort of they tend to position themselves around the center of the galaxy, and the center of the galaxy is something like 30 to 40,000 light years away. So, you know, the fact that this is only 8,200 means it's really close. I actually think it was several months ago, months and months and months ago, we looked at a globular, look at her back there, a globular that was actually the furthest away, and I don't remember how far away that was, but it was, I think it was several tens of thousands of light years away. So yeah, it's kind of interesting that we just sort of randomly stumbled on this one, which, at least according to Burnham's here, is the closest one. It is closer than Omega Centauri. It's closer than 47 Tucanae. It seems to be the closest one. And I remember last night too, we looked. One of the plots I made was a colored magnitude diagram. I think Bobby described it as like a tornado. Looked like a tornado. Well, here's what it looked like to Burnham back in 1978. So, not as many stars. So yeah, we have definitely done a step up in terms of being able to sample these stars. I think I'm out of focus again, so you get to stare at my dirty hand while I try to focus. There we go. So pretty cool. I don't think there really wasn't anything else here except that it seems to be the closest one. So yeah, I thought that was pretty cool. Definitely, if you can, you've got to be at a pretty low latitude, to see this object. But if you can, it looks like a pretty spectacular globular. Because it's so close, it seems to be really, really, really large too. So what was the declination of this thing? Let me go back to the list here. So negative 5339 ish or so. So yeah, that's going to rise about 4 degrees above my horizon. So yeah, I'd be able to see it if I wished really hard. That's about it, though. So yeah, I'm probably not going to be able to see that guy. But yeah, so let's go back over to Sinbad and start looking at a few of the references and just sort of see if there's anything else interesting about this particular thing. And that's sort of what we'll do for the rest of the time here. So I'm going to share my screen. I'll hide that. I'm going to come over here and I'm going to do that, and I'm going to do that. And yeah, you can still, I think Burnham's Celestial Handbook, I'm pretty sure is out of print. Pretty sure. But it's if you need an excuse to visit used bookstores, you can usually find, if not one or two, all three of them in used bookstores. And they come in soft cover and hardcover. I have soft cover ones. But yeah, so even though the information in Burnham's is a little outdated, what I really, really like about Burnham's is the huge amount of sort of the history of all these stars, all these objects, everything else. They really do an excellent job, talking about when these objects were first discovered and named, and who studied them, and at least what their current understandings were. Now, a lot can happen in 41 years. so
Tell me about it.
yeah. So um, some of our understandings have likely changed, but it's a very, very bright object. As you can see, it's uh, even in the visual range, it's very, very, very bright. If you go to a relatively dark site, you can see this thing. It just pops right out. So pretty amazing. Let's see if there's anything else interesting here. Proper motion. Okay, not a huge amount there. Radial velocity. See, now this is putting an angular size of 4.6 arc minutes per side, and Burnham's was saying something like around 20. So, a little bit of a difference there. Let's see. Not a lot of different names. In fact, the Caldwell number here is not listed as a Caldwell object. So don't really know why it wouldn't be. I don't know if Sinbad acknowledges the Caldwell catalog. Maybe it doesn't. It's hard to tell. We'd have to dive into that a little bit more. It does have a couple other names, as you can see here, but not Caldwell. So don't really understand why. But all right, we're going to keep going here. So as you can see, 1,723 references. That's a huge number. And the only reason why I can think now is because it's so darn close. But we'll get to we're going to try at least to get to the bottom of that. Okay, yeah. So we did the distance thing, and I'm just going to remind myself here: 3.6 times 10 to the 6th light years times 0.002. Yeah, see, at least according to this measurement, it's at 6520. So Burnham's was saying 8200. This number is 6,520 light years. So what our means of measuring distances change. Sometimes they improve. I don't know if that's an improvement or not. It's definitely different. It places it 2,000 light years closer than what Burnham's said. So it's really, really close anyway. All right, so let's see.
I wonder if you can still get Burns and current editions today, or that's just 1978 was the last one.
I don't think that they are in print anymore. I'm pretty sure. I think sometime last year on this live stream we actually looked for them, and I don't think that they are being done anymore. There might be.
Is it worth checking again or what?
Well, at some point, yeah. I don't think I'm going to today because I want to get through a few of these references. I want to see what all the excitement is about. Why is this object being studied so much when many of the objects of the day that we do here have either zero or just a couple, right? This is an insane amount of references. So here we go. We're gonna
so Tom Scott has this to say about the Caldwell according to Wikipedia. It is a list of favorite deep sky objects and not a catalog in the astronomical sense.
Oh, okay. Okay. That makes sense. That makes sense. I don't know. I mean, you know, the Messier um, catalog is also a list of favorite deep sky objects.
Yeah, kind of.
Right? I don't know what the difference there is. So yeah, okay, but I can understand that if the Caldwell catalog isn't sort of an accepted catalog, then okay, Sinbad probably isn't going to list it. But that seems ridiculous, right?
Oh my gosh! I think if we was able to stop right now, we better check on see if Burns did have a new edition.
Yeah, because PageMaster is saying new. Yeah, I would want to check the publication date of those new ones because I don't think that they're in print anymore. But I mean, I am more than happy to be wrong about that because I think they're great books. But Mr. Burnham is no longer with us, so somebody else, if there are any updates or anything, somebody else has to be doing all that work. So yeah,
Could mean a new version of his last one.
yes.
It doesn't necessarily mean new in the
True.
current sense.
Yeah.
True. So
what did you mean by new, PageMaster? That's what I want to know.
Yeah, I don't know either, but yeah, check the publication date and let us know if you want. Yes, that's absolutely true, Chuck. These days, and it's only going to get worse. It's only going to get worse and worse and worse. All right, so the references are in list by date. So I think what I want to do is I just want to search for 6397 and see if the titles of the papers get us anywhere. So okay, well here's one: the age of the old metal pored globular cluster NGC 6397 using wide field camera 3 that is on the Hubble scope. So okay, yeah, we looked at some of the Hubble images the other day. So metal poor means to astronomers that there is primarily just hydrogen and helium observed. There's not a lot of anything else. To astronomers,
makes you want to think that astro mining should be a thing when we start doing space exploration stuff.
Well,
manned space exploration, not unmanned. You know what I mean?
Yeah. Well, these are looking at the stars though too. I don't think that we have the technology to mine stars yet. Not quite yet. Not quite yet. But so yeah, this is just mentioning that we're not seeing a lot of heavier elements, right? We're mainly just seeing the light elements, the hydrogen and the helium. To astronomers, everything else is a metal, which is that's really weird and silly. But oh well. All right, let's keep going here. 6397. AGB subpopulation. So AGB is the asymptotic giant branch. It's just the giant red stars, and so I guess they're finding sub populations of those kinds of stars inside of that cluster. So probably what we're going to be seeing here is a lot of color magnitude diagrams, that kind of thing. Let's just see, because this is sort of a recent thing, published in the monthly notices of the Royal Astronomical Society last year, it looks like. Let's just let's start there. We'll go right into the ADS here, the astrophysical or the astrophysics data system. And
so they're just, so from Atalanta, the new books are just like remastered versions of the 1978, the last edition of the Burns.
Okay. Yeah.
So what they did, they just remastered the books.
Nice. Well,
no, they just have never been used, is my guess.
Right.
They
okay.
Just,
Gotcha. Okay. All right. So let's see what these folks are doing. It looks like let's see, Australia, Germany, Italy. So mainly Australians here. Cool. Pretty cool. Let's see. It's been well established that the galactic globular clusters harbor more than one stellar population, distinguishable by the anti-correlations of light element abundances: carbon, nitrogen, sodium, oxygen, and magnesium, aluminum. These studies have been extended recently to the asymptotic giant branch. Here we investigate the asymptotic giant branch for the first time. We performed an abundance analysis. Oh, high resolution spectra. Cool. Okay. So, okay, yeah, so it's not only going to be some color magnitude stuff, but they're actually looking at the spectra of some of the individual stars. So they've identified some of these AGB stars and actually measured the amounts of some of the stuff in them, right? Iron, sodium, oxygen, magnesium, and aluminum. Very cool. Shows no evidence of a deficit of sodium-rich stars. Okay. No evidence of a deficit as reported for some other globular clusters. Subpopulation RGB. Ooh, RGB. What does RGB stand for? 47 RGB. Where's, I see AGB. I don't know what RGB is. All right. Well, maybe we'll be able to find that out somehow. Identical disagrees theory, okay, which is oftentimes a comforting thing when observations match theory. Then your confidence in the theory can go up a little bit. Usually, that's how that works. So, all right, let's. We definitely don't have the time or the brain power to dive into all of this, but let's take a look at. Okay, yeah. So here are some color magnitude diagrams, right? So they have looked at a few of the stars in here. with the Johnson B filter and the Johnson V filter, subtracted those values, and then compared them to V, and you get that kind of structure. And again, let's try to find out what this RGB thing is. I really drives me insane when they do that. RGB.
You said you knew what AGB was.
Yeah, AGB stands for asymptotic giant branch.
Okay.
But I'm not sure what RGB stands for. Yes, here's AGB. Let's go.
Well,
let's go back and see if they say anything at all. Yeah, see, they just start saying RGB right here. Yeah, unfortunately, I'm not quite sure.
RGB, I think Page Masters was looking at the paper as well. It's meant for red giant branch.
Red giant branch? Huh.
Yeah.
That sounds a little weird. I've never heard that term before. Red giant branch. Okay, well, that's as good as explanation as any. It just, it's popping up here with absolutely no reference whatsoever. It's just totally annoying sometimes that they do that. But all right, well, I'm going to keep moving on here, moving right along. Okay, so here's B minus V versus V. Let's kind of see what's going on there. And then here's the U minus the I. So U is very, very, very blue. It's almost in the ultraviolet. And I is almost in the infrared. So, they're...
Okay. So, according to Wikipedia, Page Master just gave us a link about the red giant branch.
Okay.
It's sometimes called the first giant branch. It's the portion of the giant branch before helium ignition occurs in the course of stellar evolution.
Oh, okay. All right, cool.
Should I continue, or that's enough?
Well, let's all sort of take a look here. Sometimes called the first giant branch. So let's see if we can. Okay, so RGB in this case is the orange, or the orange line, or the orange points here. So okay, I guess this is the visual magnitude versus B minus V. I don't know why it cuts off like that. That's sometimes characteristic of these giant branch things. They just sort of turn on, and then you have these long tails. So that's sort of what we're seeing here, and that's why they're called the asymptotic, because they just sort of go away to nothing. So cool. All right. So red giant branch. Okay. I gotcha. I want to see some spectra. So here's some target details. Chemical abundances. Abundance results and analysis. Come on, I want to see some wiggly lines. I don't want to see any more dots. I want to see wiggly lines. So astronomers love to make these kinds of plots. I mean, I've mentioned this many times. That we try to find correlations between things, and structures inside of those correlations. So what they've done here is they, like in this case, they've taken spectra and they've measured the abundance of magnesium and hydrogen, and then they've looked at the ratio between those two, and they've then plotted that ratio to what the ratio of the aluminum to hydrogen. And yeah, you know, I mean, you're sort of seeing some interesting structures here. I think this big plus sign here, I sort of interpret that as the error bars. So, you know, instead of making each one of these dots with this plus sign, which would make this really, really busy, they've just sort of eliminated that, put it off to the side to show you what the error bars there are. So, you know, this point is calculated to be here, but it could be way up here, it could be way down here, it could be way over here, it could be way over here, right? Just like, you know, the error bar indicates. So, you know, the error bars are, I don't know if those are incredibly large, but you know, you have to take that into account when you're looking at these kinds of things. That you know, those points aren't exact. They're going to be somewhere in the vicinity. That's about it. So, kind of interesting correlation structures here, though, right? That you know, this tends to group up in one place. This sort of is spreading out this away. This is spreading out that away. Kind of neat. Not sure what that is. Kernel density estimations. Wow, I don't know about that one. I'd still like to see some spectra, but I don't think that they're going to. I don't think that they're going to show us any spectra. Nope, that's the end of the paper. Oh, that's a bummer.
Mm-hmm.
That's all right. You know, you know, they extracted the information from the spectra, made their measurements, and you know, produced these plots. So that's almost as good. I like to see lots of wiggly lines, though. That's just me. All right, so let's go back to the references here and see what other mischief. Let's maybe let's try to go all the way to the first reference here ever made. Variable star clusters. Interesting. 1898. Let's see if 6397. See if I go backwards like that. Can I do that? Thought I could. Not gonna let me. Oh, it's really not gonna let me. That's not very nice. Oh.
That's a moray.
Oh yeah, it's like completely frozen up here. Oh, there it goes. I don't know why it did that.
I think we're about to lose Atta as well.
Yeah, Atta, are you about set to turn back into a pumpkin for the day? I think so.
Yeah.
Yeah. Have a good night, Atta.
Getting close. See you guys when I get back.
Okay, sounds good. Have a great trip. Be careful. Be careful.
Yeah, have fun, Atta.
Have fun. Yes. Okay, see you later.
And don't get raided by the stage curtain.
Right. I thought I saw one here from 1952. Yeah. So a study of the magnitudes and colors of the globular cluster NGC 6397 from the Astronomical Journal 1952. Let's take a look at that, if I can. I think my browser is having a little bit of a conniption fit here. There we go. The old potato, you know. Let's see if we can grab it here from the ADS. Yes, good, good, good.
Yeah.
I like to look at these early things. Sometimes they're moderately interesting.
Thank goodness that I still have the ability to change systems on my computer and stuff.
Yeah.
Because what I'm on the Chrome OS side right now, and I think the only way you can do it right now is if you do a hard reset, and that resets everything. And also I also disabled the Android portion of the Chrome OS. So all
Gotcha.
I got is just the main system.
Right. Cool. So they are using a 26-inch refractor, right? So that is using a lens. It's not a mirrored scope. In Johannesburg, I think that's South Africa, right? So that's pretty
Yeah.
cool. So yeah, they go through, how they did all this, but they're promising some pictures here. So, okay, so there's a pretty wide field, it looks like, but then they've got these areas that I'm not quite sure if they zoomed in on those to get some more things or not, but all right, well here we are. So color indices versus blue magnitude. So I don't know what the color index is in this case. Maybe we can find out here. They're not properly labeling their axes on their plots. Bad scientists. Must be punished. Must be punished for that. Let's see if we can find out what the color index is, because that's just a difference in magnitudes. It's probably B minus V, but see if we can try to find out. It looks very. This looks very, very similar to the plot in Burnham's. Right? Remember, it went up that way, and then there was a blob of them over here too. So that's pretty cool.
And I think way back when they didn't have computers as well.
Well, in 1952, they definitely had very limited resources when it comes to computing. Yes, that's absolutely true. But come on, they can label their plots. So, trying to find out. MPGMR. Here's the color index plus 0.42. Yeah, so back in 1952, I don't know if they had I don't think they had the Johnson Cousins UBVRI filter set yet. So yeah, I'm looking at the magnitudes here, and it's saying MPG and MR. So let's see if we can try to understand what that is a little bit. Let's go back. Here and see if we can figure out what approximately, at least what wavelengths. Icon screen by Bausch and Lomb, which provided a highly neutral over and essential range of the spectrum. The average reduction is 8.1 or 1.08 magnitudes. Blah 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 blah. Huh. Oh, here. Isn't this it? Oh, okay. Yeah. So,
Chuck
so
Nackler,
here,
don't you just love abbreviations?
oh man, you know, I I have no problem with abbreviations as long as they're explained, right? Um, so yeah, photographic emulsions. Um, I guess I'm reading this that there weren't any filters used in these, but there was a red one here. So um, my guess is that since they're talking about blue magnitudes, which would be on the x-axis here, this is some kind of red minus blue magnitude scale here. So pretty, for 1952 though, that's a pretty nice plot. I don't know. It's hard to know how that was produced. Um, and yeah, I guess the the different kinds of dots indicate where in the cluster they were looking. Right, so the small black dots are towards the center of the cluster. The larger black dots are, a little more ways out. The open white dots, or I guess the large white dots, are, a little bit more out, and then the small white dots are the furthest ones out, and that's sort of indicated here, right? So 1, 2, 3, 4 are the closest ones in, and then 5, 6, 7, 8, right? Okay. N, P, and F. Wow, what is P and F? I assume that this is north. The terminology has changed. So P and F, does anybody know what? I mean, I would say this is probably east and west, but I don't know what P and F is. I'm trying to think. I don't know. But yeah, for 1952, that's a pretty awesome plot. All right, let's see what else we got here. Okay, so they've identified a number of reference stars. Oh. Okay, and I guess they even, well, they at least identified a variable star in here. It has this kind of characteristic. This E at the end is just the number of days. So this is when this variable star is either at a minimum or maximum. I'm not quite sure which one. You take this date, and then you just add the period times the number of periods you want to get when those occur. So all right, keep going here. 2 variable stars. So observe blue and red. There we go, blue and red. So here's square 1. Here, we'll zoom out a little bit here. Now this was done on some kind of either like a typewriter or some kind of a teletype of some sort. But yeah, here's I guess what you call the blue, and here's the red. You can sort of see And they're showing 2 decimal points, which is pretty good. I don't know
Now,
exactly
when you
what.
mean by teletype, you mean by radio teletype, or just like teletype over the phone or something?
Well, like a terminal, a automatic typewriter, I guess you could call it. Um, uh, yeah, not quite sure. But this looks like it's um, typed out in some way. Anyway, but yeah, they're going out 2 decimal points, which is
So
pretty good.
I guess, like you could say, they have some form of computer technology, but they use like a little teletype machine, right?
Yeah, I don't know. Don't know. They might actually have talked about that right in the introduction. Yeah, we'd have to look and see because yeah, I mean, calculating these magnitudes from photographic plates is they had devices back then to actually do that. So it was all very very manual and sort of painstaking. So in a certain sense, they did sort of have kind of an automated way of doing it, sort of. But yeah, all right, yes. So they're just identifying all these stars. They've obviously identified quite a few of them. Here's the whole list. Because of course, back in 1952, you couldn't say, check the list out at www dot, this wasn't there. So they published their entire list. And they were seeing some pretty faint stars. 15.26 there. I'm trying to see if there's anything fainter. 15.42, 15.59. So yeah, they were seeing some pretty faint stars. This is a 26-inch refractor with a photographic plate. So photographs aren't incredibly sensitive to light. Not as sensitive as CCDs are. But yeah, they were almost getting down to 16th magnitude. I don't see any 16s here. Seeing a lot of
It's kind of like a bit weird that teletype came like around, like Morse came around as well. If I read the Wikipedia right, teleprinter.
oh wow, okay, yeah, I didn't know that it went that far back, but okay, yeah,
Yeah,
this
I'm
is
gonna put the link on the
oh cool. Thank
YouTube
you,
chat so you can find out for yourself.
thank you, sir. Nice, nice. So yeah, we've been looking at this thing for quite a while. Back then, at least this is indicating no mention of distance yet. So hadn't uh, either haven't measured it yet, or these particular folks weren't all that interested in that. So all right, well, cool, very very cool. It's always kind of neat to see what the history of these things are. Um, let's. I'm noticing what time it is, so I don't want to go too much longer here. But let's take a look and just sort of see if there's anything else um, relatively recent that might be interesting. So we looked at that one. Muse 3D spectroscopy. Mapping diffuse interstellar bands in the local interstellar medium on small scales via Muse. That's some kind of instrument. 3D spectroscopy. I don't know anything about that. That's kind of interesting. A complete census of H-alpha emitters. Okay. In AppJ. Low mass variable stars. Yeah, it's very, very cool, that we can see variable stars inside of these clusters. That's fabulous. So far ultraviolet observations. That's kind of cool. I went, for that they would have had to use a spacecraft of some sort. Let's look at the abstract. I'll bet you they'll say here. Yeah. STIS, Space Telescope Imaging Spectrograph. So yeah. They're using HST. Cool. Complete census, low mass, for ultraviolet. So there's MUSE again. 3D spectroscopy of over 12,000 stars. Wow. Crowded field. Yeah, we'll have to dive into MUSE maybe at some point. Don't know anything about MUSE. Don't know why there's two papers here, slightly different references. Not quite sure why. Gamma ray emission. Cool. That's extremely high energy. Multiple stellar populations with VLT, the Very Large Telescope. Geometry. The white dwarf population. Cool. I like white dwarfs. Pretty amazing kinds of stars. Well, cool. Let's end this for today. There's, I think that we can definitely go at least another day on this. I'm kind of curious to see what the different distance measurements are. I think I'd sort of like to look at the white dwarfs here too. But yeah, I'm noticing what time it is, and I definitely don't want to go too long. Plus, we're gonna do our rabbiting thing tonight. So yeah, I think let's get out of here for now. If anybody's interested in going on to my rabbit room, I guess you call it, I will. Let's see. Can I post that again? I can post that again. Let me do it this way. Like that. Come over here. I'm just loading my rabbit page in here. That takes a couple of seconds. So if you're interested, come on over. It's just going to be a regular chat. We're going to run through a little talk that was given a few months ago about Gaia, and just sit back, chill, have some more.
I don't see that link posted on the chat.
Yeah, I'm going to do it right now. Okay, everybody, have a great one. I'm going to get out of here for now. Oh, there's a possibility that I too will be out on the what'll be I think the 5th of May. So I might be out. I will keep you posted on that. I should know in the next day or so if I'm going to be.
And on the 7th UTC, which is the 6th loco, I will not be on a panel. I'll be looking at some local wrestling.
Oh, cool. Okay. Very, very cool. Uncle Bill. All right, everybody. Well, I'm going to get out of here for now. So So if I don't see you over on the rabbit thing, I will definitely see you tomorrow. So have a great evening, a great day. Spread the word. This is all about talking astronomy, and you're just having a fun, casual, daily get-together, to chit-chat about all things astronomy and space and science and those kinds of things. So come on in whenever you like. All right, I am going to get out of here for now. So have a great one, everybody. Hold on to your hats. We are moving fast. We're moving fast, but it's super, super smooth. So yeah, it's usually not a problem. So, all right, everybody, take care. I will see you later.